Hello, everyone. So the idea for this research was we see in the news constant speaking about how Bitcoin is consuming a lot of energy, and we get all the news about how new technologies should focus in having some sustainability and meet some of the ESG indicators. So we said, well, why not look at how current research is going and how the focus of the academic community, but not only that, also looking at industry, what's industry doing, how they're trying to apply some of this technology while also considering the environmental impacts that this can have. So we took, okay, so our methodology at a higher level, so if you take something from this whole presentation, is the methodology where we take a data collection. So we went and gathered thousands of publications, from white papers to preprints to academic publications, all related to the DLT field, and then took some of those publications, labeled some of them in order that we can generate some data set with which we can use to train some language model. So in this case, we're using BERT, which is an original model before we have the current large language model like ChatGPT, Llama 2, etc. So this model uses a transformer architecture. We're not going to get into more detail into that one, but just to give you a general idea. Now, once we trained this model, the next step was to do some inference over a corpus of more than 20,000 publications in the DLT field. And from that, we can generate some information from where we can do bigger analysis. For example, looking at the temporal graphs, how the cetaceans have evolved across time, and at the same time, looking at the evolution of what's the community talking about currently. So to show you our pipeline, so we start selecting a few seed papers. These seed papers are from seminal work, such as the Bitcoin paper, we have the Ripple paper, we have Ethereum paper, etc. And then from these seed papers, we take the citations, so what papers are they citing, because that indicates that those papers that they're citing have a lot of influence. So for example, if you look at the Bitcoin paper, one of their citations is the Hashcash paper, which introduced the proof of work, in this case for span systems. So once having that, we can go and build a bigger citation network from where we can collect all this metadata of the papers being cited by these seed papers. And we go a maximum of 2 levels deep. So we take the seed papers who cite certain papers, and those papers who cite another papers. So, and we leave it there, because if you go expand it further, you get way upside the thematic of the DLT field. And then once we have that, the next step is just get the publications, get the PDFs for all those publications. You can see we drop substantially to this value, but that's because some of these publications are behind paywalls in journals. So, and we want to use just publicly available information. So that's mainly one of the limitations that we have. And then once we have these PDFs, the next step is how we can analyze this information is converted into text, and then from text, applying our machine learning model to find the relevant papers that we care, to do a systematic literature review, to understand the broader field, what's happening, where is research going, what is the interest, and then how is the consideration for ESG aspects in the broader DLT community. Right, so we start first to do the mapping to train our model. We take a taxonomy of the whole technology. This is an already established taxonomy published by a dear colleague, Paolo Tasca. So, and then we take that taxonomy and expand it with more knowledge. So we expanded with more, for example, blockchain name, and we added the idea of ESG, but applied to the DLT field. So for example, looking at energy consumption, carbon emission, user rights, etc., but specifically for DLT. So once taking that taxonomy, we can go and do the next step, which is labeling our data set. So you can see, for example, you have Bitcoin there. We can label as a blockchain name. And then we can label Merkle tree as a data structure of a block header, etc. And continue labeling this data set further and further. One thing that we face as an issue is that if you go very granular with this, your data set will be extremely unbalanced. So we have to prune this to get it only to the top level 12 categories. So where we define consensus, identifiers, ECG, etc. So blockchain name, good example I can give you is the XRP ledger. And identifier, another good example I can give you is Ripple. Although there's some confusion in the mainstream when they confuse Ripple with XRP ledger, so those were some considerations that we had in mind. And then once we have those categories, this is an example of how our data set look when we train our model. So let's say blockchain was first introduced with the creation of Bitcoin in 2008. So you substitute some of the values for the name entity that you created. And that's your data set that then generates the number of identities that we have here. So if you see there's more emphasis on consensus because most of the DLT research is in looking at consensus and improvements that can be applied to it. While we also try to get as much as possible of information of ECG in order that we can build a good data set that look at the intersection of DLT and ECG. Now, after having this data set, we can go and train our transformer-based model. This is the general architecture from the attention is all you need from the BERT paper. This architecture has been improved, changed, etc. So many types. So I just leave this as an example. We try 3 models. We benchmark our data set on them. First one, of course, BERT. And then we try Albert, which is a version that Google also released, where they made some changes to make this model a bit more light. And we also try the still BERT, which is also a more efficient, there is some compression mechanism for this type of model. One question that you might have is why is no ChatGPT here, and why Llama 2, Falco, and all this very popular large language model that we have seen, why we don't see that here? The main reason for that is that these type of models, they are currently not that good for this type of task that we're doing. Those models are really good for question and answering, but not when you're trying to identify a specific text within your the data set. So those models, they are not good for doing this type of task, which is the language task that we will focus for this project. So after we train the model, next step is we pass all the data set with all the text that we have, we do some inference, and then we can generate our predicted name entity. So we're identifying on each paper the components such as the blockchain name, consensus security, et cetera, and ECG. So having that, what we can do is a process of more filtering in order that we can find the text that we actually care and do a general analysis of that. So we start by removing papers that will have probably very few amount of text, and that's because there might be some issues when we do the conversions from PDF into text. And then from that, only finding the papers that actually are talking about DLT, because in our data set, for whatever reason, we might end up with papers that might rarely mention DLT, but we want the ones that are have a big emphasis on DLT. And then the next from these papers, finding the ones that have a big ECG content density, so they actually talk about this topic. And then from those data set that we built, we can have this citation network, where the authority indicates the size of each of the nodes. And you can see Bitcoin paper is in the middle, because it's a seminal work that had a big influence in the whole DLT field. And then for the papers that you see here, you have here the Ethereum paper, and you have other one Hashcases over there, because all of them introduce different type of technologies that then lead the whole DLT field and to further research, from Bitcoin proof of work, Ethereum with the smart contract, and Hashcash being a origin before Bitcoin came. Now, but the attention also, we can drive it. Now look at the ECG elements of this. So we can see a lot of attention being placed, even, of course, Bitcoin, energy consumption will be there. And the other one that we see is XRP. Also, we have here some attention given into the energy consumption of it, which is quite efficient. Now, the next piece that we did is taking the citation network that we built from the papers that we filter using a language model, look at how it has evolved across time in terms of the papers being cited, and then how it has evolved in terms of the name entities being mentioned. So if we take this, we see the filter citation network is going up considerably. That means a huge interest being given to the DLT field. And then if we look at which papers have the most citation across time have increased, you have Bitcoin and PPCoin and Ethereum. PPCoin, that's the one that introduced the proof of stake in between 2014. So it's a very seminal and important work. And then when we look at the name entities, you will find some interesting things here. At the very beginning, there's a big interest in security and privacy. And it's understandable because that's some of the foundation that led to the creation of the first blockchain, combining technologies that already existed. And then you will notice a switch from 2008 forward, where there's a big interest on consensus. And that's accompanied by a big interest on ESG. That speaks greatly about the research community who is paying a lot of attention and trying to improve work already existing about consensus algorithms and trying to make it more efficient in that regard. And then you see also big increase in blockchain names. That means lots of projects appearing after 2008. Now, important for this, we can zoom in directly into looking at the consensus algorithm and looking into the ESG aspects. Right, so if we go that, if you look at the evolution of the name entities, this is all the name entities that we have in our data set. You will notice in consensus, there's a big interest and emphasis from starting with distributed in the 1980s to protocol. That's because distributed systems have existed way before blockchain came into exist. So there was always interest in improving that. And then if you combine that, looking at the ESG aspects, computational power has always been an issue and a desire to look at and to improve in distributed system. And then when we look at post-2008, then you see a big increase in proof of work. So you can see it go completely up. And then, I don't know if you can see this part, but if you try to look closely at this one, that's where we see proof of stake appearing. So as an improvement in the work of, or challenging proof of work. And then here on this part, you can see a bigger attention on efficiency and of course energy consumption just going completely up. So all this speaks about the research community having this big desire and attention to continue improving and making the existing work better. So that will be all from my side. I'll try to leave some minutes for some questions. So if anyone has any question or would like me to show you something more detail. Yes.
In regards to the initial set of entities,
yes.
Did you define that set or it was discovered?
Yes, okay. Let me go back to that. Oh.
I mean before using the LLM?
Hold on. So those entities, so we use a taxonomy that already existed, that was well established. And from that taxonomy, we just expanded it with more things for ESG, and then we expanded the definitions that they had. So it was already accepted, well accepted taxonomy. Yeah.
Thank you.
Yes?
Yeah, what was the biggest insight that you got with this analysis?
Yes, the biggest insight is the community in general, from industry to academics, they're looking at to improve existing technology. So even though we might hear this tragic description in the news about how Bitcoin or how other type of projects or in general, they consume a lot of energy, that doesn't mean that there's nothing being done. So there's a lot of interest in trying to improve that, from either generating some alternative consensus algorithm like proof of stake, or from either improving some already technologies within proof of work to make it to be better in processing. So that was the biggest insight. And the other biggest contribution, at least that we have from this, is that currently, actually this has not been carried out for the DLT field. So don't know why, but it's just to shed some light into the whole field, in order that this type of information can serve people who are trying to regulate it and trying to understand it at a higher level, so without having to go read thousands of papers. So you get a bigger interest. And at the same time, applying some natural language processing. Yes?
How did you gather your benchmark, like your input data?
Yes, okay, so that's a good question. For the benchmark, so what we did was something called a five-fold cross-validation. So we split the data set into 5 pieces, using 1 piece for validation and the other 4 pieces to train the model. That's in order that we can use the full data set into it. And that was about it. And how we decide which models to pick is because we are making a prediction over 24,000 papers. So we went for the model, the Stillbird, which is more efficient, it's like 60% better an inference time than the other 2 models. And when you're working with a data set of that big, you need more computer efficiency. And considering that, for example, if you see the news, I think if you use GitHub Copilot or even ChatGPT, they're losing money every time that you do a query because it's quite expensive to do inference. So that's how we end up selecting the model that we selected, and then the benchmarking we did doing that the 5-fold cross-validation. All the way that people usually do it with this type of projects, you leave 1 piece for testing and the other piece for training your model. But we wanted to use the full data set.